Hey everyone, we are taking a look at this first lesson in Algebra 2A. This is called the language of functions. It's really just a summary of a bunch of things that hopefully you have already learned in Algebra 1 about functions. But functions are a really big deal in algebra, so this is a good way to set the scene. Okay? So you may need to pause the video if you want to get all these words written in. I'm going to kind of just do some highlights from this vocabulary section here. But starting out with what is a relation, and a relation is such a broad term that you probably have never had it defined for you before. But a relation is just pairing up two things, okay? Any two things. Obviously in math, a lot of the times those things are numbers, right? But you could map up people with their favorite color, or you could map up cars with their gas mileage, or you could map, years to cost of living increases, or whatever it happens to be. But it's a pairing up of two things. That's all a relation is. A function is a special type of relation, okay? So it's a specific type of relation. You're still pairing two things together, right? Two groups of objects. But the thing that makes a function special is that every element in the first group that you're pairing can only pair up with one element in the second group. Okay? It's a one-to-one relationship here. Now you can have some double dipping in that second group, like you can have two objects from the first group mapped to the same thing in the second group. But the big thing is that everything in the first group only has one partner. Okay? If it doesn't have that characteristic, it's not a function relationship. All right, these other four words here tend to get used sort of interchangeably, like independent and dependent, these obviously kind of go together, and then domain and range, these kind of go together, okay? And there are some subtle differences between them, but I see people just wanting to say, oh, this is the X and this is the Y, and then when we talk domain and range, they say this is the X and this is the Y. That's sort of true, okay? But the independent variable is like the thing that you're pairing up. So let me grab one of those examples that I talked about earlier. Let's go people with their favorite color, okay? The independent variable is that first group. It would be the people, okay? It's the thing that you're controlling. And then the dependent variable would be color, okay? So people, color. Or car, gas mileage, okay? Or class period and class average, all right? So the variables are like, what do these letters represent, okay? The independent variable is that first set that we were talking about, okay? Which is why we always say, oh, it's the X's, right? And the dependent variable would be that second set, the group that you're pairing up to. Domain and range are sets. These are groups of objects, right? So independent variable is talking about like, what is the thing? What does this letter represent? The domain would be like the set of all people in the world. And the range would be all the colors of the rainbow, okay? Or we could say the domain are all of the possible X values, but that might be like all real numbers. That might be all integers. Okay, and the range is the set of all Y values, but that word set is really important here. Okay, hopefully I'll be able to clarify that difference down here in example 1. So, oh, I'm sorry, I skipped over this section in the middle, and this is actually really important. So you may need to write this down. I can't remember if I left this printed in your notes. But the terminology we use when we talk about functions is we always say the something is a function of the something. And when it's written in that terminology, this first something is always the dependent variable. And this second something is always the independent variable. I'm jumping ahead a little bit here because we're going to talk about this function notation in a minute. But when we say like f of x, you've seen this before, this notation before. This is shorthand for function of x. And you see that here? Function of the independent variable, function of x, okay? So when you are trying to decide which one is independent and which one is dependent, if you see a sentence that looks something like this, that is your clue, okay? All right, so let's take a look at example 1. B of S is a function where B is the number of books in the library and S is the number of students in the school. Determine which one is independent and which one is dependent. Okay, so if we're talking about this rationally, we're saying which one depends on the other, okay? So I would say, like, if the number of students in our school suddenly increased a lot, would the number of books in the library also need to increase? Well, potentially. I mean, there's a lot of things there, right? But you could also think of it as like, would a bigger school with more students tend to have more books than a smaller school? And you would hope so, right? But the other way around really does not make sense. That if I suddenly buy a bunch of new books for the library, does that automatically mean that more students are going to come to the school? Not really, okay? So this here, the S, the number of students in the school, that is my independent variable because that is the thing that we can sort of control. Also, the fact that in this function notation, the S is inside the parentheses, that tells me that that's independent. So the independent variable would be the number of students in the school. Okay. The dependent variable is always hanging out here. This is your y value. Whoops, sorry about that bell. Okay, this is your y value. This is the thing that depends on the other. So this is the thing that depends on how many students there are. So the dependent variable, I didn't do this very well, but the dependent variable would be the number of books. Okay. Okay, let's look at the difference here between what I just wrote for independent and dependent variable and domain and range. Okay. Domain and range are what values make sense to go in place of this independent variable. So what types of numbers would make sense as the number of students in the school? Now, we have no idea. We don't know anything about this school, right? So it's hard for us to put like a specific number on it, but we know a couple of things, right? We know negative numbers don't make sense, okay? So we know it's going to have to be something that is greater than or equal to 0. Maybe even we say greater than 0, right? Because 0 students in a school, you wouldn't have a school. Also, these have to be whole numbers, right? We can't have decimals here. So I might say something like integers. You could also say whole numbers. Greater than 0. Okay? That makes sense as a domain. Now, does 3 million make sense? Probably not. Okay? You're probably not going to have a school that big, but since we don't have a firm sense of like where to draw that line, we can just say that, hey, this would be some number that's greater than 0. Okay? For our range, probably pretty similar. We know it can't be a negative number of books. Okay? We know it can't be decimals or fractions. So I would probably say, whoops, I'm writing books. Didn't mean to do that. I'm going to stick with something really similar to what we just said. I guess the only change I might make, and this could be open to interpretation, is it possible that we have some poor sad library with 0 books? I think so. So we could say greater than or equal to 0. So look at the difference in how we answered these two questions, right? Independent and dependent are talking about the variables, these letters. What do these letters represent? Okay? And domain and range are talking about what numbers make sense to go in place of those letters. Okay, so really this example is here to clarify the difference between these two things. Okay, let's keep going. Next up, example 2. Cost of renting a car, $35 a day, 40 cents a mile for mileage over 100. Okay, so this actually gets a little bit tricky. First question here is cost a function of mileage or is mileage a function of cost? Really, this is asking you which is independent and which is dependent, okay? Does the mileage depend on the cost or does the cost depend on the mileage, okay? That's how you would read this. This is your dependent variable in each of these situations. Okay? So we just have to think about which one makes more sense as a dependent variable. Well, it's not going to be like you walk into this car place and you throw down $100 and then your car stops driving when you reach that amount of money, right? Realistically, what's going to happen is you're going to drive however many miles you're going to drive, right? That's what you have control over. And then they're going to look at that mileage and then charge you for the cost. So it makes way more sense for the mileage to be in control. It makes way more sense for the mileage to be your independent. Okay? So the cost depends on the mileage. So I would say it's this first option here. Okay, the cost is a function of the mileage. If I was going to write an equation for this, I would write like C of M, where M is your independent variable and your cost depends on that M. Okay? So we actually already did this, right? We did this identifying the independent and dependent. I would say the independent is the mileage, and the dependent is the cost. Because, again, cost depends on mileage. Okay, we are doing a one-day rental, so we don't really have to worry about this $35 per day. We are for sure going to be paying this $35, but just once. Okay, so domain and range. Domain is asking what values make sense for your independent variable. What makes sense for your mileage, okay? And I would say your mileage just has to be something greater than or equal to 0, right? We can have decimals, we can have fractions, you can drive 1/10 of a mile, that all makes sense. You're not going to drive negative mileage, right? So something greater than or equal to 0 would make sense for your mileage. Now for your cost, well, we know if we're renting this car for one day, we have to pay at least $35. We could rent the car for one day and then sit in the parking lot all day, right? That'd be dumb, but we could do it. And so then our cost would just be that $35 because we'd have 0 miles, okay? And in fact, actually, this goes up to 100 miles. So even if we drove under 100 miles, that $35 is still all we're paying. So I would say that our cost just has to be greater than or equal to 35 because we know for sure that we're going to pay at least that $35. Okay, and again, we didn't have to specify integers or anything here because we know we can do decimals when we're talking about money. Okay, 3 ordered pairs that belong to this function. We can be kind of tricky about this, right? So let's go back to that example I said a second ago that we could rent the car and sit in the parking lot all day, okay? So we could drive 0 miles and we could have a cost of $35. And actually, we could actually cheat a little bit here and say, you know, as long as we stay under 100 miles, my cost is still just $35. So we could say, hey, I'm only going to drive, 50 miles, and I'm going to pay $35. I could drive 99 miles, and my cost is $35. Okay? But let's do one where we actually have to do some math. Right? So let's say we're going to drive 200 miles. Okay? In this case, we're going to pay the $35 plus we're going to pay 40 cents per mile over 100 miles. So this is 100 over. Okay? So we're doing 40 cents per mile times 100. There's a reason I picked 100 here, right? Because I'm just going to move this decimal point over twice. You could bust out a calculator here if you really needed to, but I'm going to say this is 200 miles, and then I would go 35 plus, this would be $40 for that extra 100 miles, so $75. Okay? And you could keep going. I mean, we could pick any amount of mileage that we want and figure out an ordered pair. But so again, we've got a relation here that's mapping up mileage with cost. Okay, mileage, cost, mileage, cost, mileage, cost. It is a function because every mileage that you drive spits out only one cost. You're not standing at the rental counter where they're trying to figure out, like, wait, the cost could be this or the cost could be that, right? There's a formula for it. It has to equal this one particular thing. So that's what makes it a function, okay? And our domain is, what numbers are we allowed to put in for m, right? We can put in anything above 0. What numbers are we allowed to put in for c, or what numbers would we expect to come out for c? Lowest we can get it is 35. Okay, I'm going to go ahead and break off the video here just to keep it from getting too long. We'll pick up in the next video with average rate of change.